Okay, so I'd like to start by thinking about the optimal human capital decision of a person who doesn't face any credit constraints. That is, who's able to borrow money from their future earnings or save money from their current earnings at an interest rate set by the market. And in order to simplify this problem, and to simplify our discussion of human capital investment in general, I'm going to make a couple of simplifying assumptions. So first, I'm going to assume that this worker or this human being, right, doesn't care intrinsically about their level of human capital. That is, they don't particularly enjoy school, but they also don't dislike school. School is as valuable to them as working. And the reason that they're going to school is because that's going to increase their earnings later in life. I'm also going to simplify things in our explicit modeling of this decision by thinking about someone who only has two periods of life, which we'll call youth and adulthood, and only cares about what they consume in that first period of youth and in that later period of adulthood. So as a result, we can think about this person and having preferences over these two forms of consumption given by some simple utility function. And I'll use a Cobb-Douglas utility function, again, to keep things relatively simple. So we'll say that my utility with respect to C1 and C2 is just given by the log of C1 plus some delta times the log of C2. Where C1 is my consumption in my youth, C2 in adulthood, and this delta is going to tell me how much I care about consumption in my adulthood relative to consumption in my youth. Okay, cool. So my decision to invest in human capital, to choose some level of schooling age, is going to affect me in two ways. The first way is all of the time that I spend in youth going to school is time that I'm not able to spend at work. And so as a result, my consumption in youth is going to be given by, or is going to be limited by a budget constraint that looks like this. I earn some wage, and all the time I spend not in school, where H is the fraction of my time I spend in school. And then I have to give up, I'm unable to consume any money that I leave aside for the future, right? So my consumption in period one is going to be constrained by my earnings in period one, which is my period one wage minus times the amount of time I don't spend in school, right? Minus the amount that I save. The other way that my human capital investment is going to affect me is that the more I invest in human capital, the higher my wages in period two. So I've got some wage in period two that's a function of age, and it's going to be some increasing function of age. Much like many of the functions we've worked with, it's going to be increasing at a decreasing rate. So the first little bit of school is going to do more to raise my wage than later bits of school. And just to make this simple, I'm going to use a functional form that looks like this. 2 times A times H to the 1/2, where A is something like my ability, right? So what I'm saying here is my earnings in period one, right? My wage in period one times the amount of time I spend working in period one minus my savings. My wage in period two is going to be a function of my human capital, which means my consumption in period two is going to be given by my wage in period two, so 2A H to the 1/2, my wage in period two, times 1, because in period two I'll spend all of my time working. There's no point in investing in human capital if I'm going to die before I'm ever able to recoup the investment, right? And then plus 1 plus R times S. Plus 1 plus R times S, right? Because I earn an interest rate of 1 plus R on anything that I save, and or I have to pay an interest rate of 1 plus R on anything that I borrow. Okay, great. So now we've got a set of preferences, and we've got something that looks like a budget constraint. But what we've got right now is a little bit difficult to work with because instead of having one budget constraint, we have two budget constraints. So what are we going to do to turn this into a single budget constraint where we can say something about the relative prices of consumption in period 1 and consumption in period 2? Well, what we can do is we can think about how functionally we're linking consumption in period 1 and period 2, right? The way that we transfer resources from one period to another is through changes in our savings, right? The savings S is going to link consumption in period 1 to consumption in period 2. And so one thing we might want to do is say, well, what if we solved for S in one of these functions and plugged it into the other? Then we would end up with a single function that included all the variables that we cared about. So in particular, I'm going to solve for S in the second function, this later period function. So I'll say 1 plus R times S is going to be C2 minus 2AH to the 1/2, right? So S is going to be C2 over 1 plus R minus 2AH to the 1/2 over 1 plus R, right? And then we can plug this into our period 1 budget constraint. And we can say C1 is going to be less than or equal to W1, 1 minus H, minus C2 over 1 plus R, minus 2AH to the 1/2 over 1 plus R. And from here, we just need to adjust terms to get this to look like a regular budget constraint. So I'm going to move consumption in period 2 over to this side so that I essentially have all of my consumption on one side and all of my income on the other side. So then I can say C1 over C2 over 1 plus R is going to be less than or equal to W1 times 1 minus H plus 2AH to the 1/2 over 1 plus R. Okay, so I'm going to spend a minute talking about what this budget constraint is telling us. So the first thing to note here is that this is going to be interpreted in the same way that we would interpret any budget constraint where we have two goods. Essentially, we have the price of each good multiplied by the amount of that good that we consume, right? And the total consumption in these two goods has to equal our income. So in this case, we're going to say the price of a unit of consumption in period 1 is 1. The price of a unit of consumption in period 2 is 1 over 1 plus R. And our income, right, the lifetime income that we have to work with is going to be our income that we earn in period 1 plus the income that we earn in period 2 over 1 plus R. So let's think for a second about why it is that the price of consumption in period 2 is going to be given by 1 over 1 plus R. If you think about this, right, if I decide that I want to spend $100 in period 1, what I'm giving up is the ability to save that $100 in period 1. Let's say the interest rate was 10%, and I'd saved $100 in period 1. In period 2, I would have had $110 to work with. Right, and likewise, if I wanted to spend $110 in period 1, in period 2, what I would have to give up is just $100 in period 1, right? In order to spend $110 in period 1, I would just need to save $100 in period 2. So the cost of an extra unit of consumption in period 2 is going to be 1 over 1 plus R relative to the cost of consumption in period 1. Right? The reason is I can get more consumption in period 2, right? Consumption in period 2 is less costly to me than consumption in period 1 because of the fact that I earn interest on my money over time. And for exactly the same reason, if I think about the value of my income, it makes sense that I'm going to be discounting my income in later periods, in period 2, by the interest rate for exactly the same reason. If I earned $100 in period 1, I could have saved that and had $110 in period 2. So $100 in period 1 in earnings is going to be equivalent to $110 in earnings in period 2. Right, and likewise, if I earned $110 in period 2, that would only allow me to borrow $100 in period 1. So what this is going to tell us is the present discounted value of all of our consumption versus the present discounted value of all of our income. And what we mean by present discounted value is the value of that income if we were to consume it all in the current period. In other words, the value of all of that income to us right now, today. Okay, great. Okay, so now we have a problem set up that could allow us to maximize our utility. Right? We could figure out our optimal choices of C1, C2, and H in order to achieve the highest utility level possible. But the weird thing here, and I know this is a little bit of a blast from the past we talked about this model a little bit at the very beginning of class, but I'm going to assume you guys don't remember that terribly well. If we think about the role that human capital is playing here, it's not playing a role in our preferences at all, right? All that human capital is doing is changing the size of our budget constraint, right? So as we adjust H, as we increase H, we're decreasing our income in period 1, we're increasing our income in period 2, but we're either increasing or decreasing the total present discounted value of our lifetime income stream. So if we think about the value of H that's going to make us as well off as possible, what we know is, regardless of what our preferences are, right, regardless of the value of delta or even the shape of our function, even if we didn't have Cobb-Douglas preferences here, because we like consumption, we're going to want to have the biggest budget constraint possible. Right? We're going to want to choose the value of H that makes the value of our lifetime, the present discounted value of our lifetime income, as high as possible. If we think about how we can do that, we can notice that the cost of increasing H is going to be constant, right? Every unit of H that we increase, every time we increase our human capital by an increment, the cost to us is going to be the loss of a wage, W1. But the benefit of increasing H is going to be falling as we add more and more human capital. In other words, we have a constant period 1 cost, right? We have a decreasing period 2 benefit. And so what's going to be our optimal value of H? It's going to be the point where the benefits no longer exceed the costs, right? We're going to want to invest in every level, every unit of human capital up until the unit H star, where the benefit of that unit of capital is exactly equal to the cost. If we invested any more H star than that, we would end up hurting ourselves. And the reason that we know this, the reason that we can expect that we're going to get a result like this, is because of the fact that our benefits are decreasing while our costs are constant. So how are we going to find that point? Well, we can just take the derivative of our budget constraint with respect to H. Right, in order to find the point where the change in our period 1 income is equal to the discounted value of the change of our period 2 income, we just need to take this derivative. Sorry, my goodness. We need to take the derivative and set it equal to 0. Right? So we're going to do that by saying derivative with respect to H of this whole thing has to equal 0. This derivative, right, is going to be just negative W1, this first piece. And then the second piece is going to be 1 over 1 plus R times AH to the minus 1 half. Right? This is going to equal 0. Of course, this is going to mean 1 over 1 plus R AH to the minus 1 half equals W1. Right? So I can multiply both sides by H to the 1 half, divide both sides by W1, and I can say H to the 1 half is going to equal A over W1 times 1 plus R, right? And this is going to tell me that my optimal H is going to be A over W times 1 plus R squared. So a couple things I want to note about this solution, right, for our optimal level of human capital. The first thing is, because of the fact that we're choosing human capital just to maximize income, and because of the fact that we're able to shift that income from one period to the other at a constant cost, our optimal choice of human capital isn't going to depend at all on how much we value the present relative to the future, right? This parameter delta here has played no role whatsoever in our analysis so far. And the reason for that is, if I cared a lot about the future, right, I didn't really care about my youth, what I would do is I would choose H star to maximize the value of my present the present discounted value of my earnings, and then I would save all the money that I earn in period one. Right, I would choose a very, very high value of S, spend very, very little money as a youth, and I could shift all the money that I don't spend towards my future consumption. And so if that was my plan, I would still only want to choose H up until the point that I could shift money to my future self as effectively through human capital as I could through savings, right? In other words, when the rate of return on human capital equals the rate of return on savings, which is 1 plus R. And likewise, if I don't care at all about the future, right, I'm a complete YOLO person, what I can do is I would say, well, I'm not going to spend any money in period 2, right? Let's say I had a delta of 0, go to a real extreme. What I would do is, in period 1, I would borrow against all of my future earnings, right? I would know that I was going to choose S so that 1 plus R times S, 1 plus R times negative S, is exactly equal to 2AH to the 1/2. But again, when I'm deciding whether I'm better off just earning money now and spending money now, or going to school now so that I can borrow more money, that decision would be made based on when I could earn enough money with an additional investment to earn a positive return on borrowing it, right? In other words, when it's worth it, when I'm earning more than 1 plus R, plus 1 for every dollar of foregone income. The other thing I want to point out is that our optimal choice of H is going to depend on 3 things. The first thing is our level of ability A. The higher our ability is, which is to say the more we're going to be able to earn in our future, in our second period, as a result of our human capital investment, the more we're going to invest, right? If we have a low level of ability, our human capital investment does us less good, so it'll be worth it to invest in less human capital before we would do better by just saving money. On the other hand, our human capital investment is going to be smaller the higher the opportunity costs are of our time in period 1. Remember that the cost we're incurring right now to go to school is the lost earnings that we could have gotten from working in period 1. So the higher our wages in period 1, the more significant those lost earnings are. And then the last thing is, the higher this rate of return is, right, the higher the interest rate is, the less human capital we're going to want. And the reason is, because we're investing up until the rate of return on human capital is equal to the rate of return on physical capital, the higher that return is, the fewer human capital investments are going to be worthwhile.